Question 5. A function is defined by f of x is equal to 5 over x squared plus 3x plus c. And when it says x is not equal to 0, that's because you're dividing by an x. You can't divide through by a 0, so x is not equal to 0. And c is an integer, so c will be either negative or positive whole number. So it could be, for instance, it could be -1 or it could be 10, something like that. Write down an expression for f prime of x, or we need to differentiate this. Now, in doing this, it will be good to rewrite this formula to write it as f of x is equal to 5x to the minus 2 plus 3x plus c. So when I differentiate this, I'm going to take this minus 2 and I'm going to multiply it by 5. I'm going to get minus 10x, and then I'm going to subtract 1 from minus 2. That's going to become minus 3. Plus, we have that as x to the 1. So that's going to be 1 times 3. So that's going to be 3. 1 minus 1 is 0. So x to the 0 is 1. So we've got that. And c, we can write that as x to the 0 there. So it's 0 times c. So it's just going to cancel that out. So this over here will be the expression. Then it says consider the graph of f. Now, it would be always useful to put in the graph. So let's just do that. Let's put in our graph here. So we've got 5 divided by x squared plus 3x. And perhaps we can actually just wait because we want to get that value of c. So let's firstly work out this part and we'll put in the rest there. It says find the value of c. And we are given that f passes through the point 1 and 4. So I can put that in for here. I can put 1 in for x and 4 for here. So I'm going to get 4 is equal to 5 because y is equal to 4, or the f of x is equal to 4. And I'm going to get 5 divided by x squared, so it's 1 squared, plus 3 times 1 plus c. So that's going to be 5 plus 3 is 8. And I'm going to take it over to the other side. It's going to become minus 8. So it's minus 8 plus 4 is equal to c. c is equal to negative 4. So I can put that value in here, minus 4. And I can plot the graph. I've got this shape graph here. We may need to change the window of that. But at the moment, that gives us a good idea. Now it says, there is a local minimum at point Q. Find the coordinates of Q. So in looking at this, my local minimum would be something over there. That would be my local minimum. This is just always increasing. It doesn't look like there's actually a minimum value, but here it does look like it's going down and then starting to go up. So your local minimum is going to be over there, and we can use our graphics calculator to find that. So we go to second function calc, and we're going to do 3 because we're looking at the local minimum, and I want to find the let me just move this here. Let me just clear the ink here. So I want to find the left bound, so I need to go along here and find the left bound. Here it comes down here, so I'll stop over there. That's probably left bound, and I'll say enter, and then I find the right bound. So I've got to go past that local minimum. There we are, I've gone past it, and I say guess, and I get the coordinate of that point is x is 1.4938, so I can write that as 1.49. Two significant figures should be fine, and y is 2.72, so 2.72. Those would be the coordinates of C. Then it says find the set of values of x for which the function is decreasing. So we are looking at the values where it's going down. Now, can you see if we're looking at our graph here, as we are going, it's looking at decreasing as we are going from left to right in our graph. Now, as I'm going on this part, as I'm going from left to right, my graph is actually going up. So it's actually increasing. So before x is on this side of the graph, this side over here, your graph is actually positive. But as soon as I go past 0 and I start going this way, can you see it's now coming down? It's getting less as I go from left to right, all the way till that minimum point. Then it actually turns and it starts to increase again here. So this section here is when the graph is decreasing. So it's when x is greater than 0, because it's at 0 there is actually no value. There's what we call an asymptote around the x equal to 0, and it's less than this point over here, the x value of your minimum, 1.49. That would be where your graph, where your function is decreasing. Then it says let t be the tangent of the graph at f is equal to f at p. Show the gradient of t is -7. So we're looking at this point over here, point P1 and 4, and we want to find the gradient of that it's equal to 7. Well, to do that, we would go to our gradient function. This is our gradient function over here. That's our gradient function. This one over here, f of x is equal to -10x to the -3 plus 7. So f prime of x is equal to -10x to the -3 plus 3. When we differentiate the function, it gives us our gradient function. It means that we can calculate our gradient at any point. Now the point P that we're looking at is this one over here. So P is the point 1 and 4. So I'm going to put in my x value of 1 into here, and it will give me my gradient. So f prime of 1 is going to be 10 to the 1 to the -3 plus 3. And this is minus. So we have therefore got that this over here is 1. So it's going to be -10 plus 3 is equal to -7. So we've actually shown that the gradient is equal to -7. And then it says find the equation of t. Now I'm just going to give myself some space here. So my equation is given by this formula of a straight line, mx plus c. Now, when I want to find the equation, I need to know this and this. Now, we are told that the gradient of this line, the tangent, is -7. So I can say y is equal to -7x plus c. And so all we need to know is what is c. And to do that, we've just got to substitute a value that we know about this line. And we know that this line passes through this point, 1 and 4. So I can substitute that in. I can say 4 is equal to -7 times 1 plus c. And so when I take it over to the side, the -7 goes over to the side, it becomes +7, and it becomes 11 is equal to c. So my equation would be y is equal to -7x plus 11. And then finally it says E. It says T intersects the graph again at R. Use your graphic display calculator to find the coordinates of R. So here I'm going to use this. Let me just clear this again. And we're going to put this in. So I'm going to put it in another equation here. I'm going to put in this one over here, that y equals minus 11x plus 11. Sorry, not 11x, it's minus 7x, sorry. Minus 7x plus 11, that's my equation, so if I graph it, I'll get that. Now, you can see here that this is the tangent point. This is the point where it is a tangent, and then this point over here is where it intersects the other graph. So that's the intersection that we're actually looking at. So we go to our second function calc, and we want the intersect, so we go to 5, and the first curve is that, yes, first curve is that when x is equal to 0, and we say enter. Let me go along here, so let me go to there, and I say enter, and the second curve enter, and guess, and it gives it to me, and it's x is equal to minus 0.5, and y is equal to 14.5. So we would write the coordinate of that obviously in our brackets to be minus 0.5, 14.5.